Vik Paruchuri is the founder of Dataquest, an in-browser platform for learning data science. Vik, welcome to Software Engineering Daily.
Thanks for having me, Jeff.
What is data science?
So data science has gotten a little bit buzzwordy in recent times, although the term is pretty recent itself. Right now, what it really means is it's encompassing a lot of fields. I've seen people who know only Excel that call themselves data scientists. I've seen people who are hardcore machine learning people who have PhDs that call themselves data scientists. I think the kernel of truth in data science and where it started was people who could very quickly and rapidly solve business problems. So people who had these math skills, who had this hardcore software skills that could really quickly kind of iterate, figure out a solution to a business problem, report the results, and then do it again and do it again. And I think right now what we're seeing all of these people figured out that if they brand themselves as data scientists, and companies realize that if they brand their vacancies as data science vacancies, they're just more interesting and they get more interesting people and they get more interesting kind of problems to solve. But not all companies need that. So for instance, if you're the type of company that kind of has a web stack, like one of my old companies, and you just want someone that knows a little bit of machine learning or somebody that can do a lot of web development, but maybe do some statistical modeling and so on, you don't need a data scientist, you need a software engineer. So we're starting to see this kind of like unbuckling of roles where you have data engineer, you have machine learning engineer. And I think in the future, data science will start to get closer to kind of this broad term to cover a whole constellation of roles.
Can you define those different terms? You said data engineer, I think data analyst, and data scientist?
Yeah. So data scientist is kind of close to what I was talking about. It's the person who has those hardcore quantitative skills and can kind of very quickly model things, very quickly present results, is just a good communicator. A lot of kind of skills bundled up there. A data engineer is someone who can kind of take the production side of this. So someone who isn't necessarily very quickly iterating on models. They're more taking models that have already been created and they can scale them up. So this is someone that can maybe work with Spark, that can build data pipelines, that can create the infrastructure, maybe even for other people to answer questions quickly.
What is Dataquest?
It's very, very hard to learn data science on your own. And it's very hard to learn and even know all the skills you need to kind of figure out how you succeed in a data science role. So Dataquest is a way to kind of address that. It's an in-browser learning experience for data science. So we give you tracks. Right now we have data scientist and data analyst with data engineer on the way. And in your browser, you can learn all the skills you need to kind of get to an introductory level in those careers.
So why did you start Dataquest?
So 4 years ago, I was a U.S. diplomat. I was actually posted in a tiny South American country called Guyana. I was pretty bored. I hadn't really done any coding before, but I thought software was very interesting. So I quit. I ended up learning a lot of things. So machine learning, statistics, coding, all at the same time. And I wanted to predict the stock market. So initially, before I'd learned any statistics or machine learning, my models to predict the stock market kind of sucked. And I gradually started learning more. I found this site called Kaggle, which lets you compete and practice your machine learning skills. And eventually I won some competitions. So against people with PhDs, masters, and so on. I won a couple of competitions in automated essay scoring and bond pricing. So I realized this was a field I really loved. And then I went to work at edX, which is this online education provider. And I thought, hey, edX is doing these awesome things. They're going to democratize data science, machine learning, coding. And to some extent they did, but to a broader extent, I noticed a lot of my friends were struggling with how to learn data science because they would go to these MOOCs. edX is a MOOC provider, massively open online course. And they would kind of start, they'd watch a few videos, they wouldn't really get anywhere and they'd give up. So there's this notion of kind of applied skills that no one online was really doing particularly well. And based on my own experience with learning, I realized there had to be a better way. So a way to kind of learn in your browser, do projects, build a portfolio, kind of get the whole cycle of how you actually learn something and figure out how to apply it.
Can you describe that process of learning data science in the browser?
I mean, the first and most important thing is the only real way to learn data science, I'm convinced, is to actually analyze real data. There's lots of people that will lecture at you and videos that will tell you that you're learning data science. And I've noticed a lot of beginners actually really like this because it's easy. Like you watch a video, it's nice, you feel like you're learning, but then you go to and actually try to do something and you can't. And it feels like this big disconnect. And you're like, what? The guy in the video told me how to do everything. But unless you're actually learning how to do it yourself, you're never going to learn how to actually do it. So that's point one. And point two is kind of like eventually you have to graduate. So we have these kind of like structured learning modules. So you get this introduction to a concept like neural networks. But eventually, this kind of structured learning, kind of Codecademy style, is what I'd call it, where a concept's introduced, then you're asked to write some code about it, and then you go on for a few more screens. And you're writing real code, but eventually you need to kind of take off the training wheels and build your own project or work on something on your own. Because that's when all the concepts really click, and you build a portfolio, which employers like, and so on. So we kind of try to mimic that process. We teach you concepts. We actually have you write real code. You work against real data. So we'll analyze NBA data sets. We have a UFO sightings data set in our R tutorials and so on. And then we get you ready to make projects. And we have some projects for you to try and build your portfolio and so on.
So Dataquest has 3 separate tracks. It has the data analyst, data scientist, and data engineer tracks. And you've talked a bit about how these roles differ from one another. I'd like to go through the curriculum and the personalities that these roles manifest. What tools does a data analyst learn?
Sure. So data analyst, it's kind of a little bit less quantitative than a data scientist. So it's mostly kind of looking at data, figuring out how to make reports about it, but you're not necessarily doing a ton of predictive modeling. You're doing some. So the tools you'd use really SQL. We teach a lot of Python, so Pandas is a big tool there. A lot of data analysts use Excel, which we think is a great tool, but we aren't really teaching Excel explicitly because we're kind of more focused on the programmatic data analysis. So we teach that. Also, data analysts use they do a lot of web scraping, API work, and so on. So we have some courses on that. And we also teach a lot of data viz, data manipulation, data cleaning, and so on.
What are the typical jobs that would employ somebody trained as a data analyst?
That's interesting. So, I mean, when you think about it, there are tens of millions, probably hundreds of millions of people using Excel. And what a lot of companies are finding, and I've talked to some people in finance, is a good example, a lot of financial modeling is done in Excel now. You can do it a lot more reliably, quickly, and with less people if you learn Python. So one Python programmer can do the work of quite a few Excel users. And that's not to say Excel is a bad tool. They're just kind of quicker ways to do similar tasks in Python and more powerful. So a lot of these kind of roles that used to use Excel are now shifting to tools like R, Python, SAS, in some cases SAS, and so on.
What about Tableau?
Tableau is an interesting tool. So I personally have not used Tableau because I've never had a use case for it, but I know a lot of people that do, and there's nothing wrong with something like Tableau. I think when we're preparing people to be data analysts, we're kind of taking the view that where things are moving is towards kind of like this programmatic data analyst, the person that can pull in data from a lot of sources and synthesize it. And Tableau is great at kind of the end stage of this, where you have data in a decent form and you want to visualize it, but kind of getting from point A to point B all the way out to Tableau. There's a lot of people that kind of want that full cycle and full spectrum. So for instance, like a big company can afford Tableau. A big company can pay the license fee. They can have the people who are very specialized in using Tableau. But in a smaller company, you might only have one data analyst. So you need someone who can do the whole workflow. Or even in a bigger company, you may need the people who can get the data to the point where it can be easily visualized in Tableau and so on.
So are you saying that with Tableau, it's not necessarily the tool itself that you have reservations about teaching or passing judgment on? It's just the fact that the pricing model kind of prices out a lot of people, or there's some institutional barriers to people using Tableau en masse?
Well, so let's say if you spend all your time learning Tableau, and this is actually a thing I commonly notice with people who are learning, and a mistake I made. If you learn syntax for a very specific tool, you're never going to be able to generalize your skills beyond that tool. And it's a major impediment to you getting a better job. It's a major impediment to you being able to work on your own projects. So yes, we could very strictly teach Tableau, but we teach these open source tools that teach you the principles of visualization and how to frame problems. And those skills you can carry over to as many tools as you want.
Including Tableau.
Including Tableau if you want to.
So what tools does a data scientist need to learn?
So data science, a little more quantitative than your data analyst. There is a lot of overlap, though. I mean, data scientists typically work with things like SQL. They typically work with APIs. They typically work with Pandas. It's just a little more in depth with something like Pandas. You're a little more heavy on the data manipulation side. You also need to know a bit of linear algebra and statistics, and you need to be able to kind of understand machine learning. To an extent, a data analyst maybe doesn't have to. So data analyst needs to be able to understand some algorithms like linear regression and maybe explain some of the trade-offs. But a data scientist needs to be a little bit heavier on the machine learning side. So know things like clustering and when you should use different types of algorithms and so on.
So we'll go into machine learning a little more later in the conversation. You mentioned Panda a couple times. What is Panda?
So there's a tool called Pandas. So R has been a very popular statistical language for a long time. At some point, a lot of programmers said, wait a minute, it's really hard to take R models and actually implement them somewhere. So they said, hey, why don't we kind of build this infrastructure in Python, which is a great general purpose programming language for manipulating and analyzing data. Because once we do that, it's very easy to say, hey, we have this web server written in Python. We can implement our models in Python. Now we can go deploy them really easily. So Pandas is a tool that mimics our data frame in Python. And it's very powerful. It's pretty easy to use and so on.
So what does a data engineer need to know?
Yeah, this is very interesting. And this is kind of a role that's, I don't want to say evolving, but it's becoming more kind of mass market now. It's really about how do we scale up these algorithms. And a lot of it is done in languages like Java, Scala, Spark, for instance, is a really popular kind of quote unquote big data tool is written in Scala. So a data engineer is all about how do we build scalable pipelines for shuffling data around, for scaling up our analysis and so on.
And can you give me an example of what a data engineer would need to do end to end to set up a data pipeline?
It really depends on your company and the business value. So let's say you have, let's say you're an internet advertising company and you have tons of click data. And each event is kind of very unstructured. It's very ragged. And you have kind of this guy clicked here, and then you want to convert this into how much should we price each click for? Like how much should people pay for each click? How can we set up an auction system? So a data engineer would kind of find a way to get these logs into a digestible format. So maybe you're using AWS in that case, maybe you're using something like S3 and Kinesis and so on to kind of shuffle data back and forth. And then you're writing the tools to really enable a front end to connect to those data stores, pull the data out, and kind of do whatever analysis you need to do on it. Maybe that's Spark, maybe that's Hadoop, but you're kind of figuring out how all of this works.
So is the data engineer setting up something that the data analyst or the data scientist is using on the other end of the pipeline?
So that's one side of it. The other side is taking something that a data scientist has created. So maybe a data scientist has like 10,000 rows of data, a very small set of click data, and they've created this linear regression or this other model that predicts something interesting. Maybe it can forecast a bid well. So a data engineer would also scale that up in a lot of cases to work over your whole data set.
Well, you've mentioned Apache Spark. I know Apache Spark is growing in popularity. What does a data engineer need to know to set up Apache Spark?
That changes by the day. Spark is, as you mentioned, developing very fast, and how each version is installed seems to be changing quickly as well. Right now, Spark you can set up locally on your own machine relatively easily. It gets complicated when you want to make a cluster and kind of have all these machines talk to each other and figure out how to get clients to connect to the cluster and so on.
Are there any other tracks you're planning to launch?
So we definitely want to target these very specialized roles. So for instance, in finance, you're seeing the rise of kind of quantitative analysts and financial data analysts and so on. So at some point, we want to be able to very narrowly focus our content to be able to kind of help train those people. That's not in the immediate future, but in the medium to long term, we'd love to get there.
What are the concepts that tend to elude people when they're first learning data science?
I'm going to take this question a slightly different direction. I think the thing that most beginners get hung up on is the I can't do this problem. So you look at this kind of, and it's very common in data science because there's a lot of math and there's a lot of dense terminology. So you look at this kind of paper on neural networks and you think, I could never replicate that, and you just kind of give up. So I think we need to find better iterative ways to kind of build people's capability step by step up to the point where they get it, instead of just saying, here it is, get it or don't get it.
Yeah, it sounds like almost an imposter syndrome type of problem.
Yeah. I mean, and honestly, in teaching people data science, the biggest thing you have to get over is this idea that data science is hard and this idea that it can't be broken down.
So where do your students come from? Are they coming from academia or industry, or where exactly?
Yeah, I mean, we're finding a decent mix breakdown between academics, between people who want to advance their careers. It's mostly people who want to advance their careers, and just people who are curious, which is by far the smallest segment.
Do these people tend to have some knowledge of programming before the Dataquest?
So this is really, really interesting. And we've had quite a few people who don't know programming up front. And this really excites me because I think data science is becoming potentially this alternate entry point to coding. Because there's this whole set of people that are motivated by things like machine learning and data-centric challenges that aren't necessarily motivated by building a web server. So, I mean, that's very encouraging and cool to me.
What are the advantages of learning data science versus software engineering?
I mean, it really just depends on who you are and where you want to go. That's kind of a difficult question to answer. So, I mean, there's a lot of overlap between the two. So there's lots of software engineers who know a little bit of machine learning. Obviously, you can't do data science without knowing how to code. So it's not like there's this clean line. There's tons of roles on that border, like machine learning engineer. Like data engineer is arguably one on the border too. So that's one. And two, I mean, really it comes down to what interests you. So are you the type of person that really loves reading cool fact-driven articles? Like, do you really like 538? Then maybe being a data scientist is right for you. Do you look at the world and do you say, oh man, 20 cars passed by where I'm standing and 10 of them were brown. I wonder why that happened. Why is there such a weird statistical imbalance there? Like, if you're that kind of person, then I think data science is probably right for you. If you're the kind of person that thinks, hey, I'm looking at this Tinder app. I wonder how that was built. How do the servers talk to the front end? And that's really what drives you, then engineering's right for you. But I mean, I don't know if there's a really good answer to that.
Interesting. So you've talked a bit about machine learning. What does it mean to be a machine learning engineer?
Machine learning is kind of like, think of a pyramid. And at the top, there are these researchers. And these are the people that are working in labs. They're the people like Geoffrey Hinton and so on who are coming up with new algorithms. So these are the people who are advancing the state of the art in machine learning research. And what's great about GitHub and kind of the software development practices we're doing now is these people aren't very isolated from the rest of the world. So you can have these amazing machine learning researchers who contribute to a library like scikit-learn, and suddenly you have this new algorithm that's immediately accessible to anyone. A little bit below them on the pyramid, you have these people who are taking those innovations and building scalable libraries like scikit-learn, who are kind of like enabling everyone else to actually use those advances. And then below that layer, you just have everyone that's kind of using machine learning in the wild. And this is kind of where the machine learning engineer lives. It's the person that maybe they can, maybe they can't code a support vector machine from scratch. They probably can, but they don't need to because someone else already wrote this higher performing open source version. They just know how to use it. They know the trade-offs really well. They can tune the parameters, and they can ultimately apply it to something useful. So whatever that problem is, they know how to solve it with machine learning.
So among those three tracks you mentioned, data engineer, data scientist, and data analyst, where does the machine learning engineer specialty fit in?
Most of the machine learning engineering I've done, I was a machine learning engineer before, and the people I've seen, it's like 70% engineering, 30% machine learning. So it's going to be a kind of difficult track for us to cover in the short term because we don't have a lot of general software engineering content. But potentially in the longer term.
So I'd like to go through some terms from machine learning. In machine learning, there is unsupervised learning and supervised learning. Could you contrast these two?
So a good unsupervised machine learning problem is, okay, so I have a ton of, I don't know, let's say I have a ton of flowers. This is the classic iris data set. And I want to figure out what categories I can group these flowers into. But up front, I don't have any intuition of what those categories are. So I can use unsupervised learning to automatically cluster these flowers based on some of their own characteristics. So I might figure out, hey, some of these flowers have really long petal lengths and they are all violet and they're off in their own cluster. And some of the other flowers are over here. So unsupervised learning is a way to very quickly kind of figure out the structure of your data and explore it. So it's a way to figure out, hey, there's 4 different groups here and this is what they probably mean and I need to dive more into why that's happening. Supervised learning is, let's say you want to predict how much someone will pay for an ad. You have a very definite thing you want to figure out and you have data that can actually tie into that prediction. So supervised learning is a way to actually predict the future.
And what is a neural network?
There are lots of different machine learning models. So the simplest and the one most people are probably familiar with is linear regression. There's a bunch of data points. I want to minimize the error and with my predicted values and the actual values, so I just draw a line. So it's very classic. I mean, you can predict a lot of things really well with linear regression. The thing is, a lot of things are not linearly related. So something like height and weight, if you think about it, is pretty linear relationship. The taller people get, the more they weigh in general, some exceptions. But a thing that's nonlinear is let's think about someone's credit score and their zip code. So there are definitely clusters. There are areas where people's credit scores are lower. And there are areas where they're higher. So let's say, I don't know, I think Orange County, California is a rich area. So there's probably quite a few zip codes in that area that are close in number, where the credit score is high because these people have a lot of money and so on. And conversely, there are areas where people are less wealthy and the credit score is lower. But there's no linear relationship. You can't say if I have a zip code that starts with a 1, I'm going to have a lower credit score than if I have a zip code that starts with a 7. So what neural networks can do is they're really good at figuring out these nonlinear relationships and tendencies. So they can work really well in cases where linear regression might not work. And as we've seen, they've worked really well in things like image recognition and speech recognition and a lot of things that Google's funding and Facebook's funding and so on.
What about deep learning?
Deep learning is kind of like data science. What it means is kind of sometimes hard to tease out. But so neural networks were invented, I believe, the 60s or 70s. So they've been around for a while. But very recently, people found out that if you take a lot of layers of neural networks, so you can put neural networks, and honestly, this is really hard in podcast form. If this was a video, it'd be a lot easier. But so you have some input values, and you have a value you want to predict. So let's say you're passing in a lot of images, and you want to predict what's in that image. So you basically take the images, you convert them to pixel intensity values, and you feed them into the first layer of the neural network. And this first layer is connected to a second layer. It's not really how the brain works, but people say it is. So let's say it's how the brain works. So you feed all these values to your first layer. The first layer basically reweights the values and tries to kind of learn like patterns in the image to try to make an accurate prediction. And then it feeds stuff to a second layer. And then that second layer of neurons feeds it to the third layer, and then so on until you get your prediction. And this is deep learning. Deep learning is just multiple layers of neurons in a neural network.
So my understanding is that one of the important features of deep learning is that it allows you to do sort of effortless feature extraction. Could you describe how deep learning relates to feature extraction? Maybe define what feature extraction is.
Sure. So something that I've done a lot of is automated essay scoring. So you're given a bunch of student essays, and from that, you have to figure out a grade a teacher would give it. So obviously, an algorithm can't directly be fed text. That makes no sense. Computers work in binary and digits and so on. So you have to convert text to a numeric representation before you can make predictions with it and figure out what score a teacher would have given the essay. And to back up, you have a training set. So you're given a bunch of essays, and the score a teacher already gave those essays. And then you want to predict the score on future essays. Your training set you're given, let's say, has 10,000 essays. So in order to get from I have text to I have numbers that I can make predictions with, you need to do feature extraction. So obviously any feature extraction you do is going to be lossy. You can't 100% capture all the information in a piece of text in a numeric representation. So the classical way to do feature extraction is to manually figure out what features are cool and which ones aren't. So you might look at a piece of text and say, oh, this length might be an interesting feature, I'm going to use that. Or I'll put a 1 in a column if a word occurs in the text and a 0 if it doesn't, and then I'll just have 50 columns for that. Things like that. So you manually extract features. What you can do with a neural network is you can basically convert this text to a bag of words representation. So basically each column corresponding to a certain word, and then you just feed that bag of words for all the pieces of text into a neural network, and it kind of figures out what's interesting based on that.
This essay competition occurred in Kaggle, as I understand. Could you talk more about Kaggle and how you got involved in it?
Yeah, Kaggle is awesome to start with. I honestly don't know how I got started with it. I was learning kind of. So when I first started learning coding, I was making these quote unquote models, which basically said if the stock price went up the past 2 days, we should buy tomorrow. And I created these terrible things that didn't really do much. So then I found Kaggle and I realized, hey, these people are applying machine learning to these problems. So it was kind of what drove me to learn more statistics and linear algebra and machine learning and so on. Kaggle is really companies and organizations will put data sets on Kaggle and then ask you to solve a specific challenge. So for automated essay scoring, it was, we have all these essays, we want to figure out the scores. They've also had competitions saying, here's a bunch of stock prices, figure out the stock price tomorrow, things like that. No, so it's really just a way to kind of test your skills against tons of other people to advance the state of the art. A lot of people have figured out kind of never before seen results using Kaggle.
So I would love to hear in more detail about the algorithms you used in the essay scoring competition.
So I was just learning how to program when I did that. So the final algorithm that we created our final solution with, I worked with a teammate, Justin, on the first one. It took basically 2 weeks to run. I think a week to 2 weeks. It was crazy. But anyways, it was a combination of a bunch of algorithms. So random forest. We did a little bit of deep learning stuff, although it probably wasn't called deep learning back then. Any algorithm we could find. Lots of clustering before we applied it to algorithms. We did a bunch of ensembling at the end. It was basically every single machine learning technique and every single natural language processing technique possible.
How do you use these different algorithms together? Do you set up some sort of pipeline where you have multiple algorithms just executing sequentially?
Yeah. So the really, really nice thing about machine learning is you can do something called ensembling. So one algorithm can spit out some results, and then a totally different algorithm can spit out some other results, and then you can combine them. And the most naive way to do that is just to average all the predictions. And what you find, and it's crazy, is that the more different the methodology of these two, the stronger the final prediction after you ensemble them. So you can take two really weak algorithms that produce maybe, let's say they're 60% accurate. You can ensemble them and get something that's 70% accurate. And what's I guess good and bad about working with a teammate is you want your approaches to be really, really diverse. Because if they're very similar, then when you ensemble your results, you'll get kind of not a really good final ensemble score or result. So you kind of like don't really talk to each other about your methods while you're working on them, so that when you finally do combine them, you get kind of a good outcome.
Interesting. Can you describe ensembling in more detail?
Sure. Okay. So let's say I have this piece of text and I use one method of feature extraction to convert that text to numbers. And then I feed those numbers into a linear regression algorithm to get some predictions on what a teacher would have scored, like how that would have worked. Then I take the same set of text, I apply a different feature extraction algorithm, completely different, get a totally different set of numbers. And then I feed that into a neural network. And then I get some predictions out of that. So basically, I have, for each essay, I have one number for my neural network and one number for my linear regression algorithm. So then I just average those numbers for each essay. And there are more complex ensembling strategies you can use, like weighted averages and so on. But let's just say I average them. And then at the end, my result over the whole set will be stronger than with any individual algorithm. Does that make sense?
Yes, that does make sense. You also mentioned the term random forest. Can you define random forest?
Sure. So I'm sure you're familiar with a decision tree. So let's say I want to predict whether the weather tomorrow will be sunny or cloudy. So I'm going to assign sunny 1 and cloudy 0. So I start at the top of my decision tree and I say, was it sunny or cloudy yesterday? And then if it was sunny yesterday, I go to the left. If it was cloudy yesterday, I go to the right. And then basically I'm creating I'm creating two branches in my decision tree. And then at each branch, I end up at a node. And then at each node, I can say, okay, so let me see. So on the sunny side, you might say, was it sunny 2 days ago? If yes, make another branch and go to the right. If not, make another branch and go down. So I kind of like keep creating these branch points until eventually I have a final like number. So at the end, I can say, okay, as I go through my decision tree and I make these choices, at the end, I will be able to decide whether it'll be sunny tomorrow or cloudy. So decision trees can actually be automatically created by an algorithm. And they are a machine learning model, just like neural networks or linear regression and so on. A random forest is really, really cool algorithm. It's basically a way to kind of, you change the input data a little bit and you change how you construct the trees a little bit, and you construct a lot of trees and you ensemble all the trees together and you get a much stronger prediction than you would have with any single individual tree.
Is Kaggle a significant source of income for some people?
I really doubt it. I mean, if I had, I won a few Kaggle competitions, and if I'd kept doing it, I could have made maybe a half to third the money I'll end up making, or I ended up making as a software engineer or less. And I was doing really, really well. Like they're very kind of at the top. So basically, I think 100 to 400 or 500 people will compete in one of these competitions, and it takes 2, 3, 4 months of really sustained effort to win. And then once you get to the top, there's probably 10 to 20 people who are equally smart and have done equally as much work and so on. So there's a little bit of luck involved there. So not everyone is going to win. So putting in 3 to 4 months of effort to lose, like crushing, like that's awful. And for that 3 to 4 months of effort, if you're good at machine learning, you can make way more money than you'd have a chance of making with Kaggle.
Why did you have an edge over the PhDs and other credentialed people who are entering these competitions?
Honestly, I don't really know. I suspect it was just the fact that I was trying things that other people would have dismissed. And I was just iterating really quickly, and I was spending a ton of time on it. I was just learning coding. I was just learning everything. I didn't have a job, so I was working 12-hour days, basically 7 days a week. So
Hal Varian, who is the chief economist at Google, described Kaggle as a way to organize the brainpower of the world's most talented data scientists and make it accessible to organizations of every size. Why are the data scientists on Kaggle just doing competitions rather than working at a company?
I think I was an exception in Kaggle. A lot of people, not everyone, but a lot of people use Kaggle as kind of just a side way to maintain their skills and for fun, because it's a lot of fun, and just to learn new things, not as a source of income.
I know that you parlayed your success on Kaggle into a position in edX. Can you describe that process?
Basically, build a lot of stuff, get it out there so people can see it. Start a blog so people can read your thoughts and really kind of you're seen as kind of a thought leader or someone who is worth listening to. And then people will reach out to you. I mean, this is a really hot field. There's a lot of demand for these skills. If you can prove you have them and you have a way to kind of show that you're articulate and you know what you're doing, you'll have no shortage of offers. And that's what happened to me.
So what is edX?
So edX was started by MIT and Harvard in, I think, early 2012. But basically, they offer these massively open online courses. So it's a way to educate the world for free. I think they just got to 4 million users, so it's great. They have a lot of great courses. They've been educating a ton of people.
And to clarify, edX is the company that you were working at before you decided to start Dataquest. What did you learn about online learning at edX that made you approach things differently at Dataquest?
Yeah, I mean, I think this goes back to what I was talking about before. I know a lot of people that have tried to learn using massively open online courses. And they might pick up a little bit, they might feel like they're learning, but like they just can't translate this gap between I'm listening to this video and I'm actually doing it. So online learning is great. It democratizes information. You have a lot of really, really smart professors from MIT, Harvard, Berkeley, et cetera, who are teaching on it. But it doesn't address the question of how do I, a person that doesn't know how to code and doesn't know data science, go from that to actually being able to get things done? Because honestly, like no one at a data science interview or a company or even a software company cares if you can pontificate on the underlying architecture or the algorithms. They care if you can actually apply them and use them and figure out when you should do what. So that's really what I think is missing with MOOCs and what we're trying to fix with Dataquest.
So we're planning to do a week of shows about coding boot camps. What do you think about data science boot camps?
There are a few good boot camps. I know people who've done really well. I think however talented and motivated you are going into a boot camp, is however talented and motivated you're going to be coming out of a boot camp. They're going to give you structure, but they're not going to kind of force you over the top. It's kind of a way to, if you really feel like you learn better in person and you really feel like getting some exposure to the field and connections is going to help you, and you're already super motivated, you should go to a boot camp. But you're going to have to work 60, 70 hours a week. You can't just expect the boot camp to do everything for you. That said, I also wouldn't go to any boot camp that's not top tier. I don't know all the top tier boot camps, but I mean, people like Insight, Data Science, Galvanize, that's kind of the top tier. And everyone below it's really hard for them to place people. It's really hard to get your money's worth as a student. I mean, they're 10 to 15K. It's kind of crazy. And all of this stuff you can do on your own. For most people, it's just a matter of confidence.
So, as I understand, I should ask this question. Do you plan to incorporate any coding bootcamp or physical mentorship models into Dataquest?
Not at present. We're not exploring that.
What is the future of Dataquest?
So Dataquest is a way for you who doesn't really know anything necessarily. Maybe you don't know coding. You probably don't know data science. It's a way for you to come in, be able to learn skills, build a portfolio, get job ready, and then go get a job or go advance your career. Maybe you're working with Excel now as a data analyst, and you can make way more money if you know a little bit of Python, and you can kind of add some quantitative aspect to your skills. So Dataquest is kind of a way I did really badly in college personally, and I didn't really get any value out of it. I think it's a way to help people solve this gap. Like, how do I go from this very open-ended education that doesn't really teach me much to actually being able to get things done? Dataquest is that bridge.
Can you talk more about your experience in college and how that influenced your eventual development of Dataquest?
College is funny. So I graduated with a 2.0 GPA. If I had failed one more class, I would not have graduated. I worked at UPS all through college, 30 hours a week. I feel like I learned more from that job than I did from my 4 years in college. If I could go do it again, it's hard to say. College helped me in a few ways, but it just feels like purgatory. It feels like you're there, you're not really doing what you want to do, but you're kind of just have to be there. So I don't know. I mean, it's really exciting. Dataquest is starting to be used in a couple of high schools, a couple of school systems. And I think this is really critical. It's like, how do we show students in high school that there are other paths, that if they can learn these skills, they don't need to necessarily spend 4 years of their lives somewhere.
I find it very interesting that you've gone from struggling in college, working at UPS, to doing really well and like understanding data science and computer science in depth. Like, you didn't even study computer science, right? No,
I learned to program like 4 years ago.
So, I mean, what do you think that says about like the broader interpretation? Like, I think we have, like, our culture has a broad narrative of the best computer scientists are these people that started at an extremely early age, and they learned to code when they were 9. Do you think we have a societal misconception about that?
Well, 2 points here. One, it feels like so society puts a lot of pressure on you if you have quote unquote skills. So it feels like the second you acquire programming skills, you're suddenly pressured to use them. Whether that's starting a startup, whether that's quote unquote bettering society, it feels like you suddenly don't have like time to just explore, and you don't have this freedom. The fact that I failed through college, and then afterwards I got to travel the world and do a lot of other cool things as a diplomat, it felt like I got this time to explore because I didn't really know what I wanted to do. And I didn't really care what I wanted to do. So, I mean, on one hand, I think that time was really valuable. And I think pressuring kids to learn quote unquote skills too early can take away from that exploration. On the other hand, coding is a form of exploration, and kind of making your own projects and building your own things, which I think I missed on. Because when I learned coding, it was in the context of just hacking around for fun, but it very quickly had to turn into how do I make money. I think that can also be equally valuable. So, but I don't think that it's necessary to learn computer science young, but I do think it's important to be able to explore young and like kind of engage your mind and figure out what interests you in order to be a good computer scientist, if that makes sense, or a data scientist.
So we've kind of glossed over what it's actually like to go through Dataquest. Can you give an explanation for the onboarding process and what it's like to start using Dataquest?
Sure. So The idea is you will come to our site because you are someone that's interested in data science and in advancing your career. So we're split into kind of a few career tracks. So you hit the site, you're kind of prompted to pick one of those tracks, you do, and then you see kind of all the steps that we've put in to kind of get you to that goal. So for example, for data science, we have sections on linear algebra, machine learning, SQL, and so on. So you pick one of those sections, and kind of like if you've used IPython Notebook, you'll be familiar with it. Our lessons are kind of that style. So text, a little bit of video, not a ton, mostly in the very beginner sections. But text, you kind of have to answer a question or complete some code to solve a problem, and then you do, and you move on to the next, and so on. And all of it leads up to you performing some analysis on a data set. So for instance, one of the pieces of content we have is on APIs and web scraping, and we teach it through interfacing with an API that tells you where the International Space Station is. So you'll kind of start doing that, and you'll get more and more complex with your analysis, and then eventually you answer some big question about what you're doing.
Interesting. And how does do things get more difficult as time goes on? How does the curriculum scale in difficulty with the improving talent of the engineer who's going through the series of problems?
Yeah, so our material does get more difficult over time. We also have projects and challenges, which are designed to figure out how well you synthesize the material and to really get you practicing data science on your own. So that's kind of where most of the difficulty is. Our content is it's aimed to be challenging, and it gets more challenging over time, but it's not aimed to be this like incredibly frustrating experience. Really, the projects and challenges are geared to be that kind of very difficult piece that really teaches you the most.
How is the employment for data scientists changing? Is it going up dramatically?
So the last time I checked, the field is growing between 20 and 30% a year, specifically for data scientists. The rest of it, kind of this constellation of data analysts, I think it's really fuzzy, and it's really hard to tell when a data analyst who is working with Excel starts working with Python or R, so I'm not really sure on that.
Do you think there's an increasing scope of problems that are solvable with data science?
Well, I think as you get access to more data and you get access to more information, there is more and more value to be added by analyzing that information. So 5 to 10 years ago, it might have been insane to... So cars, for instance, are getting a lot of telemetry, and there are a lot of new chips and so on in cars that can tell you direction and heading. And 20, 30 years ago, it may have been insane to try to analyze how all cars behave while they were driving. But now that you have all the information, it makes a lot more sense. So I think as you generate more data and you have more people in the field, you're going to find more and more interesting questions to solve. So yes, I guess.
Well, are there any areas that are still underexplored?
Deep learning works really well in some cases, and this is kind of the frontier of machine learning research now. Deep learning works really well in these kind of image recognition, text recognition, cases where you don't need a lot of kind of human input and human feature engineering and so on. It doesn't work as well in cases where you do, because sometimes it overfits and so on. So I think this interface between humans and machine learning is a little unexplored, and I think that's going to be a big future area of interest. So there's kind of a new field in deep learning and neural networks called transfer learning. So it's the idea that I can train on one problem and then generalize my results to another problem. I think exploring that is really interesting. How do we get by with less data, or how do we get by with suboptimal data, and how do we integrate humans into that loop to make sure we get the best possible results?
Okay, interesting. Well, Vik Paruchuri, thanks for coming on to Software Engineering Daily. It's been really great talking to you.
Yeah, great talking to you too, Jeff.